Hey Jeff, thanks for being here.
Yeah, sure, sure. I tell me a little bit more about this.
Yeah, this is basically a webinar series for students or anybody to learn more about different career opportunities in the renewable energy sector. So we just meet a new person in the industry each week and learn about what they do and how they got there and ask them questions. So it's pretty informal,
Okay.
but it's like career education really is more what it is and networking.
Okay. Okay. Gotcha. I'm sorry. I wasn't clear. Well, we do Kid Wind. I don't know if you know that or not.
Yeah, definitely. So you're with Amber and the folks over there at CSETs.
Yeah.
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 So,
Yeah.
I mean, this is a resource. We videotape these, so it could be a resource for high school students too. I mean, it's just like I
Gotcha.
said, it's really meant to be an opportunity for. We just tend to work with college students, but for students
Gotcha.
to learn more about what people are do in this industry and different types of jobs and different education paths and things like that. So it's just like open conversations.
Okay.
So.
Remy, I apologize, but I'm going to probably pop off. I am so behind on emails. I wasn't clear what it was, but now I understand, and I'm grateful for this. But I got to get caught up on things.
Of course, no worries. No worries. Understood. It was good to see
Okay.
you, Jeff.
Okay. Thank you. Bye bye.
Yep. Bye. Hey, how are you doing?
I'm doing great.
Like, oh, there we go. I had the wrong setting. I was like, why am I only seeing one person at a time? I mean, we're the only people here, but so Alina, tell me about where you're from.
I'm currently a rising sophomore undergraduate student at Johns Hopkins University.
Awesome.
I major in computer science, but have some interest in renewable energy. Um,
Wonderful.
yeah, I'm on the Hopkins Student Wind Energy team, and we
I was
just
going to say,
currently
you're
working
probably
with,
on the
yeah,
CWC team, right?
yes,
Awesome.
yeah.
Very cool. Well, I'm just down the street in Virginia, so hey neighbor. But yeah, well, thank you for being here. I'm hoping that Robert isn't having any trouble getting on. So our speaker has not arrived yet, so we'll hope that
Yeah,
he
no
joins
worries.
us.
Yeah.
But thanks for being here. Are you doing anything exciting over the summer, like an internship or just hanging out?
I'm doing a research with one of the professors at Hopkins. It's also kind of related to offshore wind in general. Focuses on the deployment process. Yeah,
Oh, very cool. Sounds good. Well, hopefully we'll get some other students here. Maybe you can meet some other folks. We may have an interesting opportunity coming up for some of y'all over in the Maryland area. I have a little bit of there's the potential that we might be able to meet somebody who's actually designed an offshore floating platform for commercial use. That would be maybe interesting for collegiate wind competition folks to meet coming up sometime this summer. So, not sure the details on that one yet, but I'll keep you posted if that tends to be something that happens.
sounds good. Yeah.
Yeah,
I have a really quick question.
of course.
Are you familiar with when well first if there's gonna be a CWC for next year?
I believe that is a little up in the air depending on
Yeah,
what the federal government does with the
right,
budget. I know that
right.
they would love to. And I do believe that if there isn't federal dollars to support the CWC, I think there's a lot of teams that are trying to figure out how they would just get industry to support them to do it on their own. So we'd like to think that there's going to be something CWC like next year in one way, shape, or form.
Sounds good.
So yeah,
Yeah,
we're
yeah.
hoping. But good question. Hey Mike, how are you doing? I'm good.
Good. Is Robert Preus still on for today?
He is.
Okay,
I sent him an email to remind him.
that's why I'm here.
And he should have the Zoom link, so I'm
Yeah,
hoping we will get him to show up here soon.
yeah. Okay, very good.
But while we are waiting, I would love to just remind everybody that we do have open applications right now for students to attend the RE Plus conference in Las Vegas in early September. So if you have any interest in going to this ginormous renewable energy industry conference, it's pretty epic. I think they're expecting 50,000 people this year, so it should be pretty crazy. But if you apply and are accepted, we provide a hotel room and free registration. So you just need to get yourself to Las Vegas. I know it's a horrible, probably time of the year, 'cause it's the beginning of the school year. But you have the opportunity to attend a career fair and also network with a bunch of different industry folks. So we set up what we call industry meet and greets, which is kind of like this webinar, but in person. So we like little half-hour meetings with individuals within the industry that you get to, kind of pick their brains and get some advice and learn about where they came from and what they do. And we'll also help you kind of navigate the show floor and all the sessions and things like that. So it's a great experience and opportunity if you can get away from school for a couple of days. And like I said, those applications are available on our website, and you can use the QR code to apply. And while we're still waiting for Robert to join us in hopes that we're not having technical difficulties, I'll check my email in a minute. I just want to remind you that all of these webinars are recorded. So you should definitely check back to our YouTube channel and see previous sessions with other folks that you might have missed. But this is our channel, and so you'll see like the last couple of talks here. But the other thing that you may want to catch up on is we did have our 2025 Renewable Energy Education Awards program last week, and there is a recording of that on our YouTube channel as well. If you want to see the amazing folks that we are celebrating, you can also watch our socials for all of that as well. So we are hoping that Robert is going to be joining us. I will check my email since I have not seen him. We can wait a little bit longer. I don't know. Mike, do you happen to have a contact for him? Because I don't have any contact information from him other than an email. I don't know if maybe you. Um,
Yeah, I believe so. Let me look it up.
see if I'll email him again, maybe. I think he said he was on vacation, but he thought he would be able to connect. I hope I didn't misinterpret that.
His mobile is 720-302-3476.
Okay. Thank
There
you,
he
Mike.
is.
I'm gonna mute myself and give him a quick call.
No, I think I saw him.
Oh, you just saw him?
I think so.
Yeah, I can see him in the
Here I
call.
come.
Oh, Robert, you're here. Thank you. Good to see you.
I am sorry. I so screwed up.
No, that's okay.
One of the problems with being retired is you don't have weekends off, and therefore you never know what day it is.
Sounds like a horrible problem to have.
Yeah. So I was in Fred Meyer shopping, and my phone let me know in 10 minutes I had this call. So I had to join a Zoom meeting for the first time on my phone.
Ah, yes, all the technology that goes with that. Well, thank
Yes.
you for being here, Robert. We greatly appreciate you being here. I just finished up some of the kind of announcements from the Repowering Schools side of things. And I'm happy to turn it over to you. But first, if you would like, we have a nice crowd here. If we wanted to just go through and just hear who our folks are on the call, so you just have a better idea of who your audience is, would that be helpful?
That's great.
Okay, well, let me see. I can facilitate this by Alina, would you like to go first and we'll just kind of go through the room?
Yeah, sure. Hi, my name is Alina. I'm a current rising sophomore at Johns Hopkins University. I study computer science, but have an interest in renewable energy, wind, offshore wind specifically. I compete with my team at the collegiate wind competition. So yeah.
Awesome. Thanks for being here. And Archie, would you like to introduce yourself?
Yeah, of course. Hey, good afternoon. I'm a master's student at the University of Wisconsin-Madison. I'm studying systems engineering. I did my bachelor's in chemical engineering, and I do research in the lab, and it has a lot to do with carbon capture and carbon storage. I have done a lot of courses on renewable energy, so I do have some context, but I'd love to learn more about it and understand what the trends are in the field. So that's why I'm here.
Wonderful. Well, thanks for being here. And Vamika,
Thank
would
you.
you like to say hi?
Yes, hello. I'll stay off camera if that's okay. But hi, my name is Vamika. I am currently doing a master's degree at the University of Michigan in Environment and Sustainability, specializing in energy systems. And I'm also doing an MBA. Reason I'm here is I'm also interning for Ørsted this summer. And while most of my projects this summer are solar, we're known for our wind portfolio. So I'm excited for this conversation.
Well, thank you all for being here. And like I said, these are recorded, and I believe I am recording right now, right? Yeah, I think I am. And so all of this will be available on our YouTube later. So if you want to share with any of your friends and colleagues, feel free to do that. And with that, I'll turn it over to Robert to say hi and tell us a little bit about what you have been up to.
Well, to give you some context, I started in wind energy in 1985. So I did a very significant amount of my career in wind energy. And in 1985, a utility wind generator was about 65 kilowatts. Sorry, I just dropped the phone. There we go. You still with me? Okay. Can you see me? Okay, good. And they had 7.5 meter blades, and they were very human scale. So part of my experience in the wind industry was watching things grow. And I can remember, I don't remember the year, but I remember an AWEA conference in Tehachapi, California, where we went through the Zond manufacturing plant, and they were just starting up their production of 750 kilowatt wind generators, which would seem small to some of you all now. But they were at a scale where there was nothing a human being could pick up except a bolt. And that's when I decided that wasn't the direction I wanted to go. And it shifted me to distributed wind. And with a small exception, I spent the rest of my career in distributed wind. I started off remanufacturing the old Jacobs wind generators from the rural electrification time period back in the 40s. And they were built at that time, and then people were rediscovering them, and so I learned to remanufacture them. And as a result, I learned to machine and weld, and then at some point realized this is limited growth, and started into designing and manufacturing small wind generators, 2.5 and 10 kilowatt. That's the area that I spent most of the rest of my career in, was distributed. And after I sold that business to folks who had the money to actually build it into something, I went to work for a couple of years in commercial size wind generators, which at that point in time were typically 2 megawatt and larger. And so I managed repair projects, end of warranty repair projects on 2 megawatt wind generators for a couple of years. And my wife got tired of never seeing me because I was gone 9 months of the year. Then I went back to work in small wind for the company that bought my business for a year or so. And then I went to work for NREL, where I could actually support the whole industry, and worked for NREL for 8 years, I guess it was, 9 years. Anyway, long time. So I've seen, and I'm not been directly involved in utility scale wind for a long time. I follow the technology and the market, and I'm intimately familiar with everything that's been going on for the last couple of decades in the small wind market. So I really enjoyed the challenges of the small wind market and wind in general. It looks like simple technology, and it's deceptively complex and challenging. Boeing tried to get into wind energy back in the 80s, and after building some of the first multi-megawatt machines, they decided it really wasn't their cup of tea, because they do very complex and demanding things like airplanes and missile systems and such, but the costs are high. And the challenge with wind is that it's got to be inexpensive, and it's challenging. So they decided quickly it wasn't their cup of tea. So I would love to hear some feedback about what people are interested in the realm of wind energy. Are you interested in the technology, or how challenging the technology is, or what parts of it, the cost, the manufacturing, the installation, the design? I've been involved in all of those things over the years, so I can easily point in any of those directions if you have areas of interest or particular questions. Anybody? Go ahead.
Maybe if you could shed some light on the technical challenges and how your efforts help sort of overcome that'd be kind of useful when it comes to small, like modular wind.
Okay, great. The big challenge with small wind is manufacturing something at that scale, because you're not doing bulk. When you do a big wind generator, basically the materials cost is a significant part. So you can pretty much figure it's going to be $9 a pound or whatever for manufacturing a blade, and then you work on tweaking that to try and bring it down, as well as making it so that it will last. One of the big challenges of wind generators is the extremely high fatigue environments, and the smaller you get, the more fatigue cycles you get, because the tip speed of the blade is about the same no matter what size machine you have. So the smaller the machine, the more revolutions it sees in a lifetime. And so for small wind generators, we see millions of cycles, many millions of cycles. And most fatigue characterizations of materials don't go that far. So essentially you have to work to infinite. Steel has an infinite point. At some point, if the stresses are low enough, it has an infinite life. You're just really not fatiguing it. Composites, a little more challenging. Aluminum, definitely more challenging. They don't have infinite life thresholds that you can design to. And while you're designing these things to be low labor and use low-cost materials, you still have to have them so that they last through this incredibly high number of fatigue cycles. In an environment that you have really only a vague notion of, because there's such a huge range of turbulence that the wind generator has to operate in. Turbulence is something that the whole industry has worked to develop better models for. Back in the early days, the Boeing machines, for example, they modeled turbulence as a change in velocity across the entire rotor. And then they found that after 2 or 3 years, they had fatigue cracks in things that were supposed to last 20 years. And they did a lot of research with, I don't know if you're familiar with, there's a thing called a hot wire anemometer. Essentially, it just runs current through a little tiny piece of wire, fine wire. And depending on the wind speed, it varies the resistance. And you can get instantaneous, because there's no cup spinning that has inertia. So you can get instantaneous readouts of wind direction, and by putting 2 of them in opposite directions, or 3 of them, you can get 3-dimensional. And they found that they were getting turbulence packets into the rotor that ranged in size from the size of a basketball to the size of a Greyhound bus. And I assume there's probably larger turbulence packets, but that was their sampling size. And that took the fatigue life of their blade from 20 years to less than 4. And since then, our ability to characterize and model complex wind inputs has improved enormously, and still the world is actually more complex. We haven't sampled everywhere, and the wind input, we have standards that everybody designs to, and every once in a while somebody finds out they've put a wind turbine in an environment that the standard never anticipated, or they have an extreme gust event that is well outside the standard. They've seen that at NREL, for instance, at the Rocky Flats, the National Wind Technology Center site. They've seen wind directions changes and velocity changes that exceed the standards for design by significant amount. So that's the world in which you have to design for, and you're going to have some exceptions, and that's where your design margins are supposed to keep you from failure.
Thank you so much for that. I just have another quick follow-up question, if that's okay.
Sure, please.
So in your, I mean, colorful career, have you ever seen, or is it possible to sort of design? So right now, from what I understand, the materials are designed with longevity in mind. But have there been any instances that you may have come across where it's optimized for a smaller scale or smaller time period, I mean, and with the idea behind it that you sort of replace the blades every couple of years or so, and you use a cheaper material because the material cost is a large factor in it. I don't know much about the fluid mechanics behind wind turbines, but I do know they just have to catch the wind. So as long as you have something that catches the wind, and if it's a composite, if it's something that's cheap, you can sort of replace it every couple of years, and I think you'll
Well,
be good to go.
yeah. There are instances where they've had design lives less than the design life of the turbine for various replacement parts. it gets to be a problem because field maintenance is a lot more expensive than putting something together in the shop floor. There's been many turbine companies that have failed because their turbines weren't reliable enough, and they had too much maintenance costs in the field under warranty. Many of them actually almost took my company down. You've got to have 2 or 3 people in the field, and in distributed wind, small wind, your sites are spread out. So it's not unusual to drive an hour or even 3 hours one way to get to a maintenance site. And then you've got to do your work, and then you've got to drive back. Field maintenance costs are enormous.
So what I'm getting is that sort of model would be idealized for a place where labor is cheaper. That's sort of what I'm getting.
Yeah, it might make sense, especially if you have sufficient volume in a localized area. You know, for instance, if you had a country like India with fairly low labor costs, and you had thousands of turbines in an area of a few hours.
Yeah.
But not in
So you're not
the
running
US
around all over the
environment
place.
and
Yeah,
a lot
yeah,
of other
yeah.
places. Okay.
Yeah.
Who else has a question?
Vamika, I see you have your hand raised.
Yes, I have a quick one, Robert. I was just wondering about your thoughts on recyclability challenges for rotor blades. I know that's a pretty big conversation just in the industry as a whole, but then also something that I've encountered come up quite frequently in communities that we go to. It's one of those major talking points, and you know, I struggle with having a good answer, but I'm also just wondering technologically and from your experience in the industry, if you have thoughts on that as a challenge and what solutions we might have.
Yeah, it's okay. So first of all, I think it's as much of a red herring as anything. But there are a lot of folks, including a number of NREL projects, working on blades that are more recyclable or being able to recycle the existing technology for building blades. But these blades are supposed to be in use, except for rare failures, for 20 years. It's not like soda cans or
Plastic water bottles.
something that's one single use.
Yeah.
You know, so it's not a volume issue. Yes, ultimately, we want to make them out of recyclable. There is research going into that. NREL has a project where they're using resins that can be melted down and reused at the end of the blade life. For instance, there's a company working at chewing up the blades and using the granules that are produced as a manufacturing additive because they add stiffness. You know, there's a lot of composite things that are used in various manufacturing. So there are efforts to do that, and it's really not a major thing. And again, I think it's more of a red herring to have some complaint. It's sort of like the environmental cost of manufacturing batteries for cars, ignoring the environmental cost of providing gasoline every year for decades to a gasoline-powered car. You know, it's just it's not a reasonable comparison or conversation.
Mm-hmm.
I mean, look at nobody's like saying, well, the slag you get from coal ash running a coal plant is produced every year the coal plant operates, and the turbine blade refuse is there once in 20 or 30 years. So not a comparable thing at all.
But they are doing some interesting things also to reuse old turbine blades. Like I've seen like playgrounds in Germany are built from like old wind turbine blades, and people are making benches out of them. And so they're trying to be creative in how they can reuse, if not recycle. So,
Yes,
and
yes,
Vamika, did you have a follow-up on that? Because I saw Alina had her hand up too.
Go ahead, Alina. I have a separate question. I'll come after.
okay.
Oh, okay. Hi, Robert. I am very new to the overall industry and everything, but I have a question more about the offtake side for distributed wind projects. I'm wondering for smaller scale projects such as distributed wind, are the developers like also eligible to receive renewable energy certificates
I don't know about
oh,
renewable energy certificates from who?
from um,
From their generation? Is that like you're getting the credits, the renewable energy
yes,
credits?
yes.
I do believe
Um,
that's a thing, right?
yes, yeah, and that's not an engineering issue, so I don't know a whole lot about
Okay.
that.
Yeah, I
Maybe
see.
Mike Berge does. He's on the call too. He was with us last week. Not to put you on the spot, Mike, if you're there. Maybe you have an answer for that one.
Yeah, so the value of the REX is so low because of it's dominated by large wind that
Right.
the costs of getting certification and keeping up the paperwork doesn't justify trying to sell those credits. So, each customer owns their machine, might only produce 1/200th what a single large wind turbine is producing. And so the market is really dominated by companies like NextEra who can aggregate the RECs from 200, 500 megawatts of
Mhm.
wind. And so the price is so low, it's just not worth it for small turbines.
Gotcha. Thank you.
Thank you, Mike. Okay, so back to the other lady,
Vamika.
Vamika.
Yes, thanks, Robert. Okay, so I'm relatively less familiar with the distributed wind energy industry, but I am wondering. I know that NREL, for example, has a competitiveness study for distributed wind, and I'm wondering, as a distributed wind professional, do you view distributed solar as a competitive technology? And then in that context, how do you sort of view the optimization of this technology for being a preferred option for different sort of customers, and broader question, just like what are the biggest challenges from your perspective around distributed wind being more competitive?
Well, now you've brought up something we could talk about for the next 2 hours.
That's a great question. Yeah.
So first of all, if you're making a sale to a particular customer at a particular site, solar is definitely a competitor. But often as not, they're as much complementary as they are competitive. And we need both. We need both a lot. Solar has the advantage of, in distributed applications, of often being able to be put on a roof, a space that's not otherwise needed to be kept clear. It's great for putting up over parking in town. It's more compatible with city and dense residential than wind is. It doesn't have as much visual concern. It's funny that people who look at thousands of or hundreds of power poles all the time go nuts when somebody wants to put a wind generator up in their view shed, but that's a whole nother subject. But wind tends to be stronger at night. during storms where there's no solar, during the winter where there's less solar. Again, this all depends on sites. Things vary a lot. There are places where in Southern California where the wind comes up in the afternoon in the summertime, and it comes up just about the time that solar is tapering off. So they're good complements in many places, which can allow you, for instance, if you want to have 100% renewable or need to have 100% renewable, it diminishes your battery storage requirements. Or if you have a different cost for self-generated and what you get if you push it back to the grid. Not every place has net metering, and a lot of net metering capacity is limited in the utilities. Once they reach that, they don't have to do net metering. So, the value of generating your own electricity varies enormously across locations and utility rules and regulations and state rules and regulations. In general, we need as much solar and wind as we can get. And since you sort of brought this up, I will point out that the capacity, the potential for distributed wind is somewhere in the same neighborhood as the potential for offshore wind. It's huge. We have from Montana and the Dakotas all the way down to Texas, we have a huge amount of the country that has a tremendous wind resource and lots of rural communities. And a significant amount of that territory is co-op utilities. That has been a real challenge because the co-ops aren't, in general, very amenable. That conversation has been changing in the last few years. Mike probably can have better comments than I can about that, but hopefully that is one of the things that will improve distributed wind is more willingness of the co-op utilities to do reasonable agreements for self-generated folks. The other thing that's not really kicked in strong that will have a big impact is the cost of storage. As the cost of storage continues to diminish, it'll make more sense for folks that can't get a good price from their utility when they push power back to the utility, will be able to store their own power and then shift it to when they need it. Let's see, anything else in that realm? Does any of what I said bring any other question up for you? Oh, I know one other thing I did want to address. The biggest challenge for wind is small wind is pushback, like I talked about with the power poles. Nobody objects to seeing a power pole on the road, but if somebody wants to put a small wind generator up in their view shed, people get nuts sometimes. And that goes away when you get established enough. Mike can comment better than I could about the in Southern California, there's an area where there's enough small wind generators that the folks that used to bitch every time somebody put up a small wind generator in their view shed started ordering wind generators, because it's like, well, if they're going to be there, I might as well have one myself. So again, the familiarity, has people let go, and it's always something new that people object to.
And I'll just throw something in there. I'm no expert like Robert and Michael are, but the distributed generation, I think, is going to play a big role as we talk about more grid stability and grid resilience. It's a challenge, but at the same time, for rural folks, that it can be a way for them to have energy, electricity when their grid goes down. So I think that a lot of people see it as a tool for resiliency in a lot of communities around the U.S. So
Yeah, in order to have that be viable, you have to have storage in the
that's true.
system.
Microgrids, I guess, is where I was going with
Yep,
that. So
exactly. And storage has been too expensive for that to be exciting as an option. And that's changing. And then what has to happen is the utility industry has to develop concepts that are financially rewarding and viable for them to have that part of this as be part of the system. Mike has a project with his utility doing a sample of that as an experimental prototype, which is very exciting. So I'm looking forward to that happening and seeing where that goes.
and with that, maybe Mike, we keep talking about you. Maybe you should just say hi and introduce yourself to these lovely folks on the call so they know why we keep talking about you.
Well, I've tried to be a lurker as much as possible.
You tried, you failed.
I'm only connecting on this because I very seldom get to actually hear Robert, who's been a long been a friend of mine for a long, long time, and I'm a fanboy of his, and just the opportunity to hear him talk and maybe talk about his history was too appealing. But yeah, I'm Mike Berge. I'm president of Berge Wind Power Company. We're a manufacturer of small wind turbines located in Oklahoma, and I'm also president of our National Trade Association, the Distributed Wind Energy Association, and I'm in my 48th year in the industry, I think it is.
Yeah. And he was our
He's the
speaker
one
last
guy
week,
I
so you
can't
didn't get to
compete with
connect. You
on
should check that out.
longevity.
Sorry. Say that again, Robert.
I say he's the one guy I can't compete with on longevity in the industry.
Neither one of us are getting any younger.
Amen to that. This December, I'll be 75.
Awesome. Bamaka, do you have another question for us?
I do actually. I was just thinking, thank you for your answer, Robert. I was thinking when you were describing the complementary nature of distributed solar and distributed wind, one of the things that struck me was installation challenges and the accessibility of installation expertise for small wind versus distributed solar. I know we're getting to the point where panels can sometimes kind of be pretty plug in and go from there. And I'm wondering, like I said, I'm less familiar with distributed and small wind. I'm wondering if you see that increased sort of installation accessibility coming to or already part of the small wind industry as well, and if there are challenges there in terms of upskilling, particularly as Remy mentioned, there's a huge opportunity here in rural areas and areas where it might be harder to get technicians out, for example.
Yeah, with a few exceptions, both in time and location, distributed wind has not yet, hopefully has not yet hit that critical mass where you've got a really well-established infrastructure and you can go in and get a permit because they've done wind before. One of the real challenges in permitting a wind application is that in most locations in this country, the permitting authority is very local. It's either a county, a township. In Wisconsin, it's townships, and there's like thousands of them in the state. And each one is their own fiefdom. So you go into them, and almost certainly you're going to be the first one who put up a wind generator in their territory. And they don't have any rules for it. And they do have rules that you need a special exemption for anything over 35 feet tall. That goes back to when, they hand pumped water for firefighting and pulled the fire engines with horses. And the rules have outlived their usefulness by a long shot, but they're defended now as a viewshed issue. And when you have to get a special permit, that can be a huge expense or delay or both. You may have to buy a permit or pay the filing fee for a permit and then have public hearings. And then people come in and say, well, these things are terrible. They cause cancer. They made my dog go blind. I mean, the stuff that comes up is truly amazing. I've worked underneath 2-megawatt machines, and often they're so quiet you have to look up to see if they're running. Now there has been instances of large machines that were noisy under some circumstances. That's ancient history. They know how to deal with that now. They know how to design blades that aren't noisy, for instance, and it's also been an issue for a few small wind generators historically. And again, the technology is developed so that's not an issue for most turbines today. But if you think about what a difficult thing it is, I mean, you're talking about a project that's maybe less than $200,000, maybe in the $100,000 range. And now you've got to spend months, maybe more, maybe a year or more, getting a permit and spend money to do that and maybe don't get it. That stops a lot. Roger, Nixon? Yeah, anyway, he just finally, there were counties that if somebody called him up and wanted a wind generator, he said no, because it is too difficult and too likely to not succeed to get a permit to put it up. And he would have to travel to the county for a hearing. The county had their meeting and they went through their agenda and they didn't have time for it. So they put it off till the next month, and then he'd have to travel again, and they may not get to it the next month. And just the thing that's the one thing that may keep small wind from reaching critical mass to continue to drive the costs down and to increase the familiarity and acceptance would be the barriers from permitting, and that's probably the most important thing. The technology is coming along nicely. Mike produces turbines that produce power like 5 cents, and are quite reliable and productive in a range of wind resources. So the technology is definitely going to get better, and it's well into viable and competitive with solar in many, many applications. More questions?
This has been a fantastic conversation, Robert. I really do appreciate it, and I appreciate all the amazing questions you guys have been asking. I have a last question if nobody else does. And that would just be if you could leave these students with a bit of advice as they are finishing up their college career and looking into the industry, if you have any words of wisdom or advice as they travel this last piece of their educational career.
Sure. What I will tell you is that at some point you're going to have to make a decision, and you may change it. It's not like once you make it, it's immutable. Between whether you're going to be a specialist in one particular area or one particular part of technology, and whether you're going to become more broad-based. And because I started my own business, I also because some of my background, but I became more broad-based. I was not an electrical engineer. I'm a mechanical engineer by training, but I've worked extensively with electrical engineers and with aerodynamicists. And to me, the most exciting part is the integration. And there are a scarcity of people that do integration well and work with and can talk to and understand electrical engineers, mechanical engineers, aerodynamicists, and other kinds of manufacturing specialists, and can pull a team's efforts together. And the biggest mistake is often that the management will be too focused in one area. They'll be either too focused in marketing, which is very common, or they're too focused in the mechanics or the aerodynamics or the electrical. And they'll make decisions that make the rest of it not work as well, or be harder to make work as well, instead of the integration of all those things, which is really, to me, the fascinating, challenging part of it. And so even if your field isn't wind, most things that are big, exciting things to do in life are going to involve a lot of specialties. And if you learn to interact with and listen to and be able to understand different expertise than your own, it will be fun and challenging. And, if you're a person who, just really loves to focus down on the detail in one particular area, hey, that's fine too. But don't automatically write that that's the only way to go, unless that's just really what sings to you. Because ultimately, at the end of the day, you're going to make a living, and you might want to do something in a way that you really enjoy it. I certainly have.
Well, that's wonderful advice, and we definitely appreciate you being with us today, Robert. I am gonna just close by reminding everybody that we do have another speaker next week, and we will be switching over to solar for a bit. So we will be hearing from Dan French, who works with our solar summits and the solar farm summits. He is a great person to get to know and is super excited about agrivoltaics. So I'm sure we'll be talking about that a little bit. So we look forward to seeing you next Wednesday. And I hope you all have a great week. And thank you again, Robert. And thank you, students, for being here. And, share with your friends. And hopefully we'll see you next time.
Thank you.
Thanks,
Yeah.
Remy.
You guys have a great rest of your
Thanks,
week.
Robert.
Thank you so
Thanks,
much.
everybody.